Good morning, sir. My name is G. Kiran Kumar. I am from ECE Section B, and my topic is Underwater Sensor Network for Smart Disaster Management. Let us go to the topic Underwater Sensor Network Applications. The 75% of Earth's surface is covered with water in the form of rivers, canals, seas, and oceans. Plenty of precious resources lie underwater, which are required to explore. The key to successful exploration has been technology dependent. Recent advances in technologies have led the possibilities to do the underwater explorations using sensors at all levels which were not possible previously. Accordingly, underwater sensor networks UWSN is emerging as enabling technology for underwater explorations. UWSN is a fusion of wireless technology with extremely small micro channel sensor technology having smart sensing, intelligent computing and communication capability. UWSN is a network of autonomous sensor nodes which are spatially distributed underwater that sense the water related properties which as quality, temperature and pressure. The sensed data can be utilized by variety of applications that can be used for the benefit of humans. The sensor nodes, stationary or mobile, are connected wisely via communication modules to transfer various events of interest. Underwater communication is mainly done with a set of nodes transmitting their data to beyond gateway nodes that relay the data to nearest coastal monitoring and control station are called remote station. Generally, in UWSN, associate transceivers are used for communication. The associatic waves are low frequency waves which offer small bandwidth but have long wavelengths. Thus, associatic waves can travel long distance and are used for relaying information over kilometers. UWSNs are utilized for a wide range of applications such as monitoring the marine environment for scientific exploration to commercial exploration as coastline protection to underwater pollution monitoring. From water-based disaster prevention to water-based sports facilitation, UWSN offers a promising solution to ever demanding applications. However, UWSN applications are exciting but challenging at the same time. The reason lies in unpredictable conditions of water environment which create serious constraints in the design and development of such networks. The focus of this paper is to survey the available UWSN application. The paper for the focus on classifying the applications and presenting a summary for each class. The rest of paper is organized as follows. Section 2 discuss the general architecture of UWSN. Section 3 discuss the recent research contribution in the field of UWSN and provides a detailed application classification. The challenge and opportunities for UWSN are delineated in section 4. In the end, section 5 concludes the. Now, let us see the image of underwater sensor network architecture. Let us know briefly about underwater sensor network architecture. In this section, we discuss the common UWSN architecture, which are basis for designing the UWSN application. UWSN architecture, one dimensional 1D. UWSN architecture refers to a network where the sensor nodes are developed autonomously. Each sensor node is stand-alone network itself, responsible for sensing, processing, and transmitting the information to remote station. A node is the type of architecture can be floating below by which can sense underwater properties, or it can be developed underwater for a particular period of time to sense information and then float towards the surface to transmit the sensed information to the remote station. It can be autonomous underwater vehicle AUV, which dives inside the water, sense or collect the underwater properties and relay the information to the remote station. In 1D UWSN, the nodes can communicate using assoid, radius, radio frequency, or optical communication. Moreover, the typological nature of 1D UWSN is star, where the transmission across the sensor mode and the remote station is carried over a single hole. Let us see the two-dimensional architecture of UWSN. Two-dimensional architecture refers to a network where a group of sensor nodes are developed underwater. Each cluster has a cluster head. The clusters are fixed as they are approached at the underwater surface. Each member of the cluster gathers the underwater data and communicates it to the anchor node. The anchor node gathers the information or data from all its member nodes and relay it to the surface beyond nodes. In 2D UWSN, the communication is carried in two dimensions. That is, first one, each member of cluster communicates with its anchor node with a horizontal communication link while. Second one is the anchor node communicates with the surface beyond node with vertical communication link. And RF communication can be used depending on the type of application and nature of underwater environment. In 2D UWSN, associates communication is preferred for underwater anchor node and the surface beyond node due to typical high distance between them. For the cluster of nodes, the network arrangement can be star, mesh, or ring depending on the application requirement. The 2D UWSN can be used for both type critical delay tolerant application. Let us see some of UWSN application. UWSN application has monitoring, disaster, military, assigned navigation, sports. Monitoring contains again three applications: water quality, habitat, exploration. And habitat contains again three parts: marine life, fish frames, reefs. And disaster application contains floods, volcano earthquakes and tsunami, and oil spill. And in the monitoring, exploration also contain two applications: natural resources and pipeline and cables. And military applications contain three applications: mines, submarines, surveillance. In this type of network, the sensors are deployed underwater in the form of clusters and are encroached at different depths. Due to the deployment of sensors at variable heights, the communication between the sensor gets beyond the two dimensions. There are three communication sensors in the architecture. First one, intercluster communication of nodes at different depths. Second one, intercluster communication. And the third one is anchor beyond node communication. In all three types of communication scenarios, associate optical and RF links can be used. Four-dimensional UWSN is designed by the combination of fixed UWSN, that is 3D UWSN and mobile UWSNs. The mobile UWSNs consist of remotely operative underwater vehicles ROVs to collect data from the anchor's node and relay the data to the remote station. ROVs can be autonomous submersible robots, vehicles, ships, and even submarines. Each underwater sensor node can be autonomous in the relaying the data directly to ROVs depending on how close that particular sensor node is to ROV. The communication scenario between ROV and underwater sensor node depends on the distance and data between them, and either associate or radio can be used. As the transmission is to be directly relayed to ROV, the sensors which are large data and close to ROVs can use radio links with the sensor which have small data to transmit, or far from RO we can use acoustics links. Underwater wireless sensor network application classification. UWSN applications are rapidly gaining popularity for enabling advances in the area of ocean monitoring and observatory systems, deep sea surveillance, tracking of various entires of aquatic environment, and unearthing resources. UWSN find their application in fields like offshore oil and gas extraction, oil spills, military surveillance and reconnaissance, mine detection, pollution monitoring, natural calamities like tsunami and hurricane forecast, coral reef and habit monitoring of marine life and fish farming. A comprehensive classification of potential UWSN applications. This section presents a survey of recent developments in the domain of UWSN application. At the subclasses top level, we classify the UWSN applications as monitoring, disaster forecasting and management, military, navigation, and sports, which are going to have a significant impact on the underwater world and provide benefits to the humans. We then further classified monitoring, disaster, and military applications into relevant subclasses. Monitoring applications. Underwater sensor refers to a network of sensor which is deployed underwater to monitor the underwater environment. These characteristics, properties, or any subject of interest, these applications are particularly related to monitoring the physical environment. Underwater monitoring applications can further be classified into water quality monitoring, habit monitoring, and monitoring underwater exploration. Let us see briefly about these three types. First one is water quality. Water is the precious resource and it premier factor for survival of living things under or above the water surface. Therefore, it is important to monitor the quality of water. The underwater quality monitoring applications vary from monitoring water quality of canals to ocean. Habitat. Underwater habitat monitoring deals with the study of environment of any living organism living over in the water. It is one of the most interesting yet challenging fields of natural sciences. Habitat monitoring, when considered underwater, becomes even more challenging due to underwater conditions. UWSN can also be used for ecosystem monitoring applications. Underwater habitat monitoring applications can be further classified into marine life monitoring, fish swarm monitoring, and underwater plants reef monitoring application. Marine life. Marine life monitoring applications deal with the monitoring environment of various species living above the water or underwater. AmicNet is European founded project designed for underwater marine environment monitoring. AmicNet is a underwater associate sensor network which is capable of monitoring marine environments such as fishes and any human or non-human activity within the coverage area and used for geological surveys. The authors have developed protocol based on the TDMA master slave mechanism for data transfer across the sensor nodes. Underwater exploration. There are large number of minerals present underwater, which is required to explore such as oil and gas. Also one has to meet the water and while joining one end of the surface with another, which matter is covering the large part of Earth's surface. The exposed remaining dry surface of Earth is connected by lying cables underwater. Underwater cables are designed with bring some of most basic social necessities such as oil, gas pipelines and fiber optics cables. Therefore, UWSN can be explore the precious resources and also to monitor the underwater pipeline and cables. Underwater exploration and applications are further categorized into underwater natural resource exploration and cable and pipeline monitoring application for underwater oil and disasters. Generally, the natural disasters are inevitable. Among others, water based natural disasters are more dangerous and produce huge destruction to the earth. Accordingly, disaster monitoring and preventive mechanisms are very necessary. UWSN offers a wide range of applications for management and recovery of such disasters. More particularly, it releases to the monitoring of events that aggravate a disaster aftermath, along with resources for comprehensive monitoring of the vast area of water. The task becomes even more challenging with occasionally ruthless weather. Therefore, efficiency monitoring of marine and aquatic dynamics is a significant research challenge. UWS monitoring strategies for disaster management and prevention can be formulated into a wide variety of applications such as floods, underwater volcanic eruption, underwater earthquakes and their resulting tsunamis and oil splits which led to above the water and underwater ecological inabilities. Floods. The reoccurrence of a flood and its increased frequency have pushed the researchers to find ways of timely flood alerts. The alerts need not only be placed in urban shores and hence require remote development. UWSN helps develop solutions of underwater sensor developments with over the water relay agents to calculate aquatic. The designed system consists of sensor module, observatory module and transporter module. The sensor module is responsible for monitoring under and gathering water related parameters such as level, thrust and intensity of water as flood indicators. The information is transmitted to the remote station for further observation. The purpose of observatory module is to be observe the information and predict the flood. The transponder module is used for relaying the information. In case of the flood, the designed system is simulated and tested in perspective of its efficiency. By varying the number of nodes developed versus the time delay, the system is also tested for its localization error and the area of coverage. Conclusion. It was observed that a good number of applications are associated by UWSN for the harsh underwater environment. UWSN has become one of the prime focuses for researchers. If these applications are properly exploited and created, a lot of lives, time and money can be saved. Although UWSN has seen a tremendous amount of growth in past few years, there is still a room for ample contributions, particularly in the physical development of the system on large scale. Thank you.